All right, people are slowly coming on. We'll try to do what we did yesterday by hand today, which really isn't too bad once you understand what we're actually doing. So if you understood yesterday, hopefully this isn't going to be too bad. So, I'm not sure if anyone else is going to join us right now. I'm just going to get started. They can watch the rerun of this if they need to. So we're going to look at modeling data by hand today. So you can always go through Google Sheets and check this out and see what makes sense and what doesn't. You can always graph this by hand and see what's going on. But let's look at it a little differently today, and let's see if we can pair up linear, quadratic, and exponential equations to tables of data and then assign a function to it, or actually get the rule. So if it's linear, it's going to follow y equals mx plus b. If it's quadratic, it's going to be in standard form of a quadratic, which is y equals ax squared plus bx plus c. Or if it's exponential, it's going to equal y equals a times b to the x. So we're looking at this table here and seeing if it follows one of these patterns. And the first thing I'm going to tell you, and this is for your notes and stuff like that, this is going to follow the linear model. This is a linear equation. So I am going to tell you that, but we don't really know that right now. The way I know it's linear is because I'm looking at changes in x and changes in y. As x changes, you will note this jump here is plus 1. 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 Over here, you have what's called a common difference, and that should not be a new term. You looked at that when you did arithmetic sequences a while ago, probably in years past. But we have a common difference here. Differ x. Right? And our common difference here is plus 4. Right? You'll see that negative 2 to get to 2, you add 4. 2 to 6, add 4. 6 to 10, plus 4. 10 to 14, plus 4. And you'll note you have a common difference. If you have a common difference, you're looking at a linear equation pretty much. So if we have a common difference, think linear equations. Here our common difference is 4 on the y and 1 on the x's. Think linear equations. Once you get the idea that it's a linear equation, okay, you're going to fit it to the model, which is mx plus b. So you already know your b term here because it gives you the 0, because remember b is the y-intercept. So your equation for this is going to look like y equals mx plus b. You need to figure out your slope, and you need to figure out your y-intercept to get your actual rule here. So here you're going to look at your slope equation. If you recall, was y2 minus y1 over x2 minus x1. And you can pick any points you want for that. Or you can look at your common difference for that. You can see your changes in x are +1 and your changes in y are +4. So you know your slope is going to be 4/1 with y's on top, x is on the bottom. That's how your common difference is going to play in, which reduces down to just 4. So you know your slope here is 4 due to the common difference. And again, that's looking at both of them. Remember, it's rise over run, so the common difference of your y's over your x's. If this went by 2's and this went by 4's, then it would be 4/2, which would reduce down to just 2. So keep that in mind. It's not just looking at this side. I did look at this side as well. There's your x side, there's your y side. And then I reduced it to get 4, and your y-intercept was 0 equals, or when you plug in 0, you get 6. So this here is your suggested model. Once you get your model, you're going to want to test it, check it to make sure. So you're going to pick some values, but do not pick 0. Do not pick x equals 0 when testing. Because 0 does a lot of weird things. 0 is going to negate this number, so you don't know if that number is going to be right or not. So don't pick 0. You can pick the other ones. 1 is not the greatest either because weird things happen when you multiply by 1. It negates things, but it should work. Just pick a couple points to test. If you're going to pick 1, pick another one as well. Make sure you feel confident in your function. So let's look at this one here. Let's see what happens when we plug in 2. If we plug in 2 to this, you get y equals 4 times 2 plus 6, and it should be equaling 14. So we're trying to get 14, but we don't know if it will or not until we actually do it. And 4 times 2 gives you 8. 8 plus 6 equals that 14, so it checks out. It works for that one. Let's try another one just to make sure everything is doing well. Let's put in -2. And here we'll get -8 plus 6. -2 should be equaling -2. And -8 plus 6 does equal -2. So that one checks off as well. So this here is your equation for it. You can also check this by going into Google Sheets and actually telling it to find the equation for it if you would like. But that is the model of our equation. So to recap, we learned that this was linear because it had common differences. Once we knew it was linear, we fit it to this model, and we found our other values, our m and b. Here you would have to find your a, b, and c. Here you would have to find your a and b, and it fit to that model. Linear should be pretty easy because you've been doing it all year. In fact, I just did this with 7th grade yesterday, so you've been doing it last year too, hopefully. The quadratic and the exponential ones might be a bit different. So let's look at those. What we're going to do is get rid of what I can, except for that. And I'm actually gonna leave common difference here because we're gonna look at that. Your common difference is gonna lead to a linear equation. Let's get our next data set. So here's our next data set. Looking at it, your negative numbers are giving you fractions. Your positive numbers are giving you whole numbers. And one way to look at it is that, hey, this is actually growing pretty quickly. And doing so, you should be thinking exponential because exponential grows quickly. So my guess is that it's exponential. It actually is. And again, I'm going to give you that just so you know. But let's look at our common differences. Right? If we were to subtract these two, you would get a number less than 1. And this one here, when you subtract them, you'd get 2. So, I mean, obviously there's no common difference in the y column. And there is a common difference in the x column, but again, you're just adding by 1. But what's happening in the y column here is you're actually getting what's called a common ratio. And that means we're actually multiplying by something. You're actually multiplying this by 3, right? 1/9 times 3 gives you 3/9, which reduces to 1/3. So you got that 1/3. 1/3 times 3 goes to 1. So you're multiplying by 3 here. 1 times 3 is 3. 3 times 9 is 3. You have a common ratio here of 3. And that's important for exponential functions. So when you see that common ratio, you're thinking exponential functions. So common difference, if this was subtracting or adding, right, you'd think linear. If this was multiplying the difference, or a geometric function, or a sequence, sorry, it would be a common ratio. And there's your common ratio. So you're thinking y equals a times b to the x. Now, you got to fit it to this equation. So what you're going to do is you're going to plug in your common ratio as, let me just double check, I think it's the b value. That your common ratio is going to be your b value here. So this will be your b value. So it's going to fit this model where your b value is your common ratio. So I'm going to rewrite that as y equals a times b to the x. And now in order to get your a value, you're just going to plug in a point and see what it comes out to be. So we're going to go ahead and plug in 0, because that would be the easiest, right? If I plug in 0, then I get y equals, I'm sorry, not y, 0 is 1, equals a times b to the 0. And you know b to the 0, or 3 to the 0 here equals 1, so it's going to be 1 times a times 1, or 1 equals a times 1, and therefore a has to be 1. Right, well, divide by 1, and 1 equals a. So you know a should be 1. So you're thinking the model should be y equals 1 times 3 to the x. And again, you don't need the 1 when you do that, so it's just going to be 3 to the x. And then you're going to actually check your work. You're going to actually take a couple of them, and again, don't take the 0 value, because weird things happen when you take the 0 when you're checking. But let's check the 1 value. If we plug in 1, right, y equals 3 to the first. That should equal 3, and 3 to the first does equal 3. Let's check the 2 value. If I square it, 3 squared gives you 9. That works. What if I took the negative 1 value? 3 to the negative first, remember your negative exponents, that just flips your fraction around. So this was 3 over 1 to the negative first. It's going to become 1 over 3 to the first, which becomes 1 over 3. And that checks out. If it was negative 2, it would be negative 2. And that would check out as well. So this here is going to fit our function. Again, common ratio, think exponential function. Common difference, think linear function. And then you just kind of, your common ratio will be your b value. And you plug in a point to get your a value. And then you test some to make sure it's making sense. So pretty straightforward there. The last case you're going to look at is the quadratic. Let's get rid of this and that. I'll leave everything else. And let's look at a quadratic function. So again, this one here is going to be quadratic because, you know, that's what we're left with. And I am telling you it's quadratic. But how do I know this is quadratic? It's actually going to be very similar to linear. I'm going to look for those differences. So here we got a +1, here we got a +1, here we got a +1, here we got a +1. Here, 16 to 2 is a minus, what is that, 14? A minus 14. 2 to 4 is a minus, or I'm sorry, is a plus. 2 goes to 4, you add 2. 4 to 20 is a plus. 4 plus 20 minus 4 gives you 16. 20 to 46 is a plus 26. And this doesn't look like much of a pattern here, but what if we look at our differences and we take the differences of those? So here we got negative 14 minus 2 is what we actually want to do, right? We want to find the differences. So negative 14 minus 2 gives you a negative 16. So I have to actually adding 16 to get between those two. So that's a plus. Is it a 16? 16 should be getting common differences. I don't know why this isn't working. Am I doing this wrong? 16 to 2. So negative 14. That's because I wrote this table wrong. I skipped the 1. Let me fix that table. That's why that's not working. That's why I skipped an x value. Here we have negative 1 goes to 16, 0 goes to 2, 1 goes to negative 2, 2 goes to 4, 3 goes to 20, and 4 goes to 46. And you'll note that the difference is these are actually now plus 1. I skipped this one here last time, so make sure you check on that. And do the plus 1. Over here, your differences are looking at, what is that, negative 14. This is 2, that's positive 4, or you subtract 4 from it. 2 to get to negative 2 is minus 4. Negative 2 to here is plus 6. 4 to 20 is plus 16. And 20 to 46 is plus 26. And then you're looking at the differences between here. Let's look how we go from these ones to there. You'll note that here you're adding 10. Here you're adding 10. Here you're adding 10. Here you're adding 10. So you have a common difference of 10 between your common differences. And this here is what we call a second common difference. So if you have a second common difference, you're going to be looking at quadratic. And say, hey, this here is a quadratic function. Excuse me. So you're looking to fill in this model, y equals ax squared plus bx plus c. And you know c here is going to be your y-intercept, just from before when you were graphing things. So you know that c here is going to equal your y-intercept, and here that's going to be 2. So you already know that one. That one's pretty easy to get. Your common difference here is going to play a strange part. And let me just double check that I'm going to tell you this right. Actually, I don't think it's going to, your book is only getting into ax squared, so you really only need to know for ax squared, I guess. So let's do it just for the ax squared. Let's fit it to that model. In this case, once you identify that as quadratic, you just plug in to solve for a. So that's not too difficult here. So we're going to pick a value and plug it in. I don't know, let's plug in that one just because it's, no, that has 46 in it. Let's plug in, let's plug in this point. So when x is 1, y is -2. So 1 squared is a times 1. Divide by 1, divide by 1, you get -2 equals a. So your a value should be -2 here. And let's double check to make sure that works and I didn't make a mistake. So we're going to say y equals -2 x squared. Let's look at it and see what actually comes up with it. Again, we're not going to plug in 0 to check because zeros are going to do some weird things. In fact, 0 is not going to work here. We know we have our c value, that's why. It doesn't actually fit this model. This is might have a plus something in there. So let's see if the c value works. +2. That seems to be working. You plug in 0, you get 2. Plug in 1 squared, -2. That's not going to work. So there's a b value to this one. This was a bad example for your book. It's getting a little more in depth than you need to know. But I think your book just wants you to fit to ax squared. So try to fit it to that. And again, you're going to do that by just plugging in a value to get there. I'm sorry, I picked a bad example. Because it is going to be ax squared plus bx plus something, and your book's not getting into how to find the b value of everything. So you're only just looking for ax squared for your quadratics. Don't worry about the b value. They're going to be pretty simple quadratics. With that, if you could do page 563, 7 through 12 for today. Tomorrow we will just go do some review on everything and be ready for a test next week. Probably Tuesday or Wednesday. And that's going to determine on what my meeting is like today when we talk to everybody. So I'll let you know about that tomorrow. With that, I'm going to end it. Again, it's about identifying which type of function it is and then applying it to the right model. And you're more than welcome to check your work through Excel or Google Sheets like we did yesterday. So if you have questions, send me an email. Talk to you later.